Okay, sir. Demand participants ඇතුළට ගමුද?
Yeah, I already did it. We can proceed within 1 or 2 minutes. They are joining now.
Recording in progress.
මේ Zoom එකේ meeting ID එකයි password එකයි ඉල්ලන්න. එහෙම කියනවා ඒ කට්ටිය.
लाइव की स्टार्ट करूँ ने माइक ऑफ कर ने
Hello. Hello.
මේ Zoom link එකේ මොකක් හරි අවුලක් තියෙනවනේ. PC එකෙන් එන්න බෑ කියනවා.
මේක ඉකෝ වෙන සිද්ධියක් තියෙනවා. තාම අපි උඩට යන්න පොඩ්ඩක් බලන්න හරියද කියලා. උඩ channel එකට යන්න බලන්න හරියද කියලා. channel එක බලන්න.
A very good evening, everyone. I'm Hassan and I would be the moderator for the day, and I hold immense pleasure in welcoming you all to Aerotech. So, What is Aerotech? Aerotech is a 2-day webinar workshop organized in collaboration of IEEE Students Branch of SLTC and SEDS chapter of SLTC. So on this Aerotech 2-day webinar workshop, what will we be looking into? As I said, it's a 2-day webinar. So the first phase is today and the second phase is tomorrow from 4:30 p.m. onwards. So today we will be looking into all about RC drones. So the major topics that we will be looking into is how to build an RC drone, legal issues, and possible career opportunities. So before moving into the session today, I have a couple of announcements to give. So first would be, you might have already noticed that chats and the mics are disabled. That is to just ensure the flow and the continuity of today's session. We would like to have 0 interruptions, so hence chats and the mics are disabled. But don't worry, I know people would have a million questions to ask. So there is an opportunity. We will have a question and answer session right after the guest speakers session. And there is a special website for this. The link would be shared. I guess it's already shared on the chat. Through this link, it'll take you to a website where you can post your questions there, and we'll pick the questions to ask from our guest here today. Please do note that we do have a time frame, so we won't be able to entertain all the questions, but don't worry, we'll try our best. You've got another option too. You feel free to use the raise hand function, and one of our members from the technical team would unmute you and you can shoot your question straight to the guest. Secondly, we have the participation limit today. We are sorry to inform that we can only accommodate 300 participants for today's session only. But for tomorrow's session, we could accommodate around 1,000 maximum participants. But yet, don't worry, we do have this session in parallel on live platforms. IEEE Students Branch of SLTC Facebook page and SEDS SLTC Facebook page. On both of these pages, you can view live, and also from IEEE YouTube channel, you can get connected to us live. Last but not least, we have one fun session. So just to tease your knowledge on today's session, we have a Kahoot quiz. So don't worry, it's just a fun session just to tease your mind. So without further ado, why don't we go into the session? So I did mention about a guest, didn't I? Yes, so who is this guest? A very special guest who is joining us today to share his valuable knowledge. He is the PhD Honours in Aerospace Technology, an engineering instructor at Sri Lankan Aviation College, certified drone pilot Civil Aviation Authority of Sri Lanka, and the Vice President of Formiflyers RC Flying Club. He is none other than Mr. Samira Wickramarachchi. Sir, how are you doing? Well?
I'm doing well, Hassan. Thank you very much. May I turn on my camera as well for you guys to see?
Sure, sir, sure.
Right.
Great. So we have Mr. Samira here. So one small announcement before we go into the actual session. We do giving participation certificates and under 3 criteria. So please do note this, participants who have already registered for this session beforehand, and participants who stay connected throughout the session. Also during the session, somewhere in between, we will share a link which you have to fill to mark your attendance. So filling these 3 criteria, you will be awarded a digital certificate, which would be delivered to you within 2 weeks of time. So without further ado, and without boring you guys with all these announcements, I guess I'll hand over the session to Mr. Samira. So sir, the session is yours.
Brilliant. Hi, everyone. I hope you had a nice day today, apart from the, of course, the severe weather that we're having right now. I hope that everybody's okay, and hope everybody's well. So as Hassan told you guys that we'll be talking about RC drones, but in particular, we'll be talking about RC aircrafts today. So let me share my presentation with you guys, and then along the way, if you have any questions, you may raise the hand and ask. And there is another platform that Hassan has mentioned that you can basically ask questions on that platform as well. And in the meantime, I know there is a bit of a language barrier here. So if you have any issues, do let me know. I'll try to explain in Sinhala as well. Right, let's start the session today. So as mentioned, we'll be talking about drones and model aircrafts, but in particular today, we'll be talking about model aircrafts, and the rest will be talked about tomorrow's session. So we'll be talking about types of drones as well as type of model aircrafts and applications that we can sort of use those particular aircrafts, and drone certification and pilot certifications, which we'll be talking about tomorrow. But it's going to be very interesting for you guys who are interested in this subject, and potential career opportunities that, of course, now we are having this COVID situation. Now everybody is sort of in a sort of a dilemma about their job and the career that they might have to change. So we'll talk about what we can do with drones to make an income as well. Also today, if the time permits, I'll talk about a new technology that the world has sort of evolved around right now, is 3D printing. So I'll talk about how to design, how to print, and what are the applications, and also career opportunities which you can have with 3D printing. Right, let's move on. Okay, so model aircraft. I'm sure that everybody has seen a model aircraft. This is, when you talk about a model aircraft, it's basically similar to a real aircraft. So everything works as if a real aircraft does. And only thing is it's basically scaled down. So when you talk about a wing, the control surfaces and everything works a similar way to a real aircraft. So before we go into sort of building an aircraft, let me talk about the fundamentals of how an aircraft fly. So I think that's a main thing that we need to know. So even though we know how to build an aircraft, we need to know how it actually flies. Then we can do our own thing onto the particular aircraft, and then maybe do some modifications onto it. And then maybe let's say like when you're flying an aircraft, if you think that, okay, this is not behaving as it should be, then if you know how an aircraft works, then you know what to do with it. So model aircraft, as I mentioned, is basically a remotely piloted aircraft. But having said that, these model aircrafts are not drones. I emphasize that word. These are not drones. For this particular aircraft to be a drone, there are some criteria that needs to be satisfied. That I'll come to on a later slide. I'll tell you how a model aircraft becomes a drone. And the other thing is, now when you talk about a model aircraft, it can be a static model aircraft. It can be sort of there as sort of like, on your cupboards, so that it looks nice. So we are particularly talking about an aircraft which can fly. So it's not a static aircraft. It's basically an RC aircraft. So RC in the sense, it's a radio controlled aircraft. Moving on. Let's talk about the principles of flight first. So normally you have 4 forces acting on a particular aircraft. So these are the main 4 forces. I'm not going to go into very deep details onto this, but I'm just going to keep it very simple for you guys because of the time constraints that we have right now. And if you have any questions, as I mentioned before, please do ask. So normally an aircraft will have 4 forces. The first of which is the weight of that particular aircraft. So that is basically the gravitational pull that is pulling the aircraft onto the ground. And opposite to that, obviously, if we were to fly the aircraft, we need to have a lifting force. So that is the lift, which is basically generated from its wings. And also when the aircraft needs to go forward, so it needs to have some thrust. So this is generated by a power plant or some sort. And opposite to thrust, you'll have drag. So normally, the higher the thrust you have, the higher the drag. It's like Newton's third law. But I'm not going to go into a lot of details, but let me just be very brief on these things. Right, so now you know that you have 4 forces. These are lift, weight, thrust, and drag. Right. So how does a lift is created? Like how does a wing create lift? let me be very, very basic on this. I'm hoping that you have seen basically a cutout of a wing. So normally it's cambered. So basically the top surface is basically rounded, but the bottom surface is flat. So the reason why it is like that is basically, for example, if you think about two air particles hitting the front of that wing, the wing tip, so the particular air particle which actually goes on the top of the wing has to travel more distance because it's curved than the lower air particle which is traveling on the bottom part of the wing, right? Does it make any sense? So basically the path for the lower particle is basically straight, but the upper path is basically rounded. That means you have to go further up and then go down to meet at the end point. So that means the upper particle, which has to go further, in order for that particular particle to go and meet up with the lower particle, has to go faster. I hope that makes sense. So when the particles on the top of the wing go faster than the lower particles, so you automatically create a vacuum. So the particles are less on the top of the wing than the bottom. So that in turn create a low pressure area, but the velocity, the speed of the particular particle is fast, but having a low pressure area. And you all know that air goes from high pressure to low pressure areas, right? That is how the wind sort of happens and things like that. So what happens is when the lower part of the wing has a high pressure area and the upper part of the wing has a low pressure area, so you have particles trying to move upwards where the low pressure area is. In turns, you have a force acting on the wing itself, creating lift. I hope that you guys are sort of following me on this. This is like bit extra details for you guys, but this is sort of fundamentals that you need to know about. Like if you're building an aircraft, you need to know how it flies. So likewise, if you're building a car, you need to know how it actually drives. Likewise, you need to know how an aircraft flies. So this is how it works. Moving on, let's talk about the primary flight controls. Now, this is very important. Now, I will use the words ailerons, elevator, rudder, thrust, and things like that. So in this particular picture, you can see that you have ailerons on both parts of the main wing, an elevator, which is on the back of the tail part of the particular aircraft, and the rudder. So to give you an example of how these things work, I have a model aircraft. As I told you before, this is a static model aircraft. I think you might know this aircraft as well. This is an A380. So this is where the rudder is, right? And this whole section of this aircraft is called the empennage, or the vertical stabilizer and horizontal stabilizers. So you have the rudder and you have the elevator and you have the ailerons on corners of the main wing, right? And how it works is basically, so let's talk about the elevator first. So as I said, the elevator is here. So when the elevator moves upwards, the air which actually comes and hits the elevator, it pushes the elevator down, right? So when you move the elevator upwards, this actually in turns push the aircraft down from the back, right? So in turns, the aircraft actually, the nose actually lifts up, right? Likewise, the ailerons on these two sides, one can be moved. Let's say one side goes up, but remind you that the elevators works in opposite ways. So if some ailerons works in opposite ways, that means, so if one side goes up, that means the other side basically goes down. So I'm just using very basic terms here. So let's say if this one is pointing upwards, that means the elevator surface, aileron surface of it is moving upwards. That means it's actually pushing this side of the wing down, but this side, it's actually moving down, move downwards. That means it's actually pushing this way. So ailerons, what it does is basically helps to rotate the aircraft, like bank the aircraft left or right. right? So elevator, up and down, ailerons, right or left, banking. So what does the rudder do? Okay, so similarly, rudder is here. So you can move the rudder surfaces left or right. So when you turn the rudder to this side, that means basically the front moving air will hit that rudder surface and basically push the aircraft towards this side, right? Does it make sense? So when this is turned like this will push this way, and to the other side, it will push this way. So basically, this is the movement which the aircraft is gonna take when the rudder movements are applied. So basically, as you can see, this is how it works. So this is called yawing, yaw movement, and pitch axis is elevator. And obviously longitudinal axis or banking is done by ailerons. Hope you did understood that. Right, let's get to the next part of the RC aircrafts. I've actually included a bit more details on flight control, so flight control surfaces. So obviously you can see the rudder, the elevators, the ailerons, but you have horizontal stabilizer, as I mentioned, and vertical stabilizer as well. And also there are something called flaps and slats. So flaps and slats are basically a high lift device. So what it does is basically it will increase the lift of that wing. If you can remember the previous slide, which I showed you how the lift is generated, the lower part of it is straight, right? But what the flap and the slat would do is basically extend that front bit as well as the aft bit, or the trailing edge bit of the wing, which in turns makes the aerofoil or the wing much more lenient for more lift capabilities. And also you have something called spoilers. Spoilers, as the name intended, is basically it's basically spoils the air moving on top of the wing. It's located on the top of the wing, and when it's deployed, it's basically spoiling the airflow, which means the lift is reduced on that particular side or both sides normally, and then it's basically used to slow down an aircraft, or maybe even sometimes it's used to turn the aircraft left or right as well. Right. So here you can see a flap and a slat being deployed on the leading edge, which is in the front of the wing, and the trailing edge, which is on the back of the wing, is called are the flaps and the slats. So you can see those are extended, and that the surface of the the air particles which has to move through is considerably more than the when it was retracted. So you have generated more lift, right? And there's another picture of the spoilers, which I showed you before. So spoilers normally are deployed when an aircraft lands. You might be able to see if you've seen an aircraft lands, or something on top of the wing basically gets deployed. So it basically spoils the air which is going through the wing, and then it basically acts like an air brake. But sometimes spoilers are used if you want to do sharp turns, just for that particular side which has to go down. Right. So moving on to RC model aircraft. So now I believe that you guys have got to know the basics of flight, and that how an aircraft would work. Now let's build an aircraft. But before we build an aircraft, we need to figure out what sort of an aircraft that we want to build. Because some people might be very good in flying an aircraft. Some people are not that good because they need to have the practice of flying. So if you are getting into this hobby, if you're a newbie who's getting into this hobby, I would strongly recommend buying or maybe building a trainer plane. So trainer planes are very easy to fly. Those have very limited capabilities such as banking. And so these words I've told you as before, ailerons, elevator controls, and rudder controls and things like that are limited. So that's more easier for a user to fly the particular aircraft and learn the basics of flying an RC plane. And also you have gliders. So glider is basically a an aircraft which actually uses thermals in the sense, so you see in a sort of a hot day, you can see that the air is moving up. Sometimes you can see some tornadoes and things like that. So those are something called thermals. Sometimes you can even sort of push the aircraft through the air and then fly itself without even having a thrust or a thrust generated thingy on this particular aircraft. That means you don't particularly need an engine for this or a power plant on this, but you can basically fly it as a sort of a glider. The name itself says glider. And sports plane and aerobatic planes, those are pretty much similar. These aircrafts can fly upside down, do all these aerobatics things, and go fly fast as well. So those are bit into more advanced sort of for pilots who are more practiced on flying an RC aircraft. And then moving on to scaled planes, these are basically the real aircraft but scaled down. So what a user or somebody who's willing to sort of build this particular aircraft, they can even download the real aircraft sizes, like let's say a blueprint of the particular aircraft, and then they can scale it down to whatever the size they want to, and then they can build the particular aircraft. And also you have float planes, which is basically a normal plane but fixed with floats. That is for, let's say, if you're flying on a lake, which you can do, take off and land on a lake, those kind of things. Warbirds are basically also scaled aircrafts, but those are very common because these are modeled after all these World War I, World War II, and World War III aircrafts. So that's there. And also you have jets. Jets are basically now all this, but before all the aircrafts that I mentioned uses a prop, or on this particular case on gliders, obviously you don't need any power plants. But the jets, in the sense, most commonly used are EDFs, or electric ducted fans. But I'll talk about those things in a bit more further on. But just so that you know, there are commonly 8 types of aircrafts that you can have if you want to build an aircraft. Let's say that, okay, now you have selected what you want to build. Let's say that we are going to go with the basic aircraft, but you need to figure out, okay, what are the materials that you need? Like, if you can buy these things in Sri Lanka or maybe in other countries, especially these days with COVID and all that, because you're mostly at home, you have more time to work with. But if you don't have the materials, obviously you can't build it. So let's talk about that. But before that, let's talk about what are the basic requirements, what we need to build this particular aircraft. So airframe, obviously those 8 airframe types you can basically buy or maybe build as well. Power plant, obviously you'll have to buy from some outsourced company or some company. And electronics, transmitter and receiver, batteries, and optional accessories, which I'll talk about in much more detail in a few more minutes. Right, let's talk about the airframe. So now if you have decided on an aircraft that you want to build, now you can choose from either foam or balsa. These are mostly commonly used, even in Sri Lanka, even in other countries, are these 2 materials. Now, foam made and balsa wood made aircrafts, they have different plus and minus points. So, for example, a foam made or EPO, EPP, those are sort of, to give you in a very basic terms, it's basically a rigiform. A rigiform made aircraft, you can carve it at home, you can cut it with a knife, you can sand it down, you can do all kind of things, you can do a lot of shapes on it, which is very easy. And obviously these materials are very easy to find. So most of us tend to go with either EPP, EPO, or maybe another sort of a material that is very easy to use. Do we have a question? Hassan, do we have a question? I see somebody has raised their hand.
Yes, sir.
I don't see any questions here on my chat. So if you can sort of narrate
No,
to
so
me,
there
then
are
I can
there are a
answer.
few questions. Yes.
Right.
So we do have a question. How to define propulsion efficiency?
Right. Propulsion efficiency is basically the prop size and the motor. So basically, what you are giving the basically what's the power that you're giving to that particular motor and the output that you're getting from that particular motor. So for example, let's say that you have I will talk about these things which with bit more detail in a few more slides, but just to answer his question. So let's say that you are giving like 1 kilowatt of power to a particular motor, and you're getting around the thrust rating will be around 100 kilograms or maybe watt hour or whatever. So from that you can basically define what's the efficiency of that prop. Does it make any sense?
Yes, sir.
Okay. Any other questions?
We can continue with this session, sir. Right.
Okay. So so as I was saying, so we have foam mades as well as balsa or MDF as well. So foam mades, the plus points are, as I said, these can be sort of easily found from any hardware shop or any place that this is sold, and you can easily make a shape out of this particular material at home. So you don't need any specialized equipment for this. Basic hand tools will do. And the other plus point is that when it breaks, you can basically easily glue that back together. On the other hand, balsa obviously are very, very hard to find these days. That's one thing. And the other thing is to get a proper finishing of this, like for example, this picture, you can see a skeleton of the aircraft. So normally when you say balsa wood, you would only make the skeleton of that particular aircraft with that particular material. And then there is something called covering film, which actually it's like a sticker. You cover it with it, and then the finishing obviously looks much better to a foam-made aircraft, and the durability is good. But the only thing is with this RC hobby, what you need to understand is eventually you will crash your aircraft. That is not, you're not going to crash, but eventually you will crash it. So when you crash it, you need to know how to repair it as well. So when it comes to balsa, especially when you spend quite a lot of money laser cutting it, or else you can even do it at home with some tools, but it's very difficult and time consuming as well. And then you'll have to, for example, if that particular airframe crashes, then if you have a breakage on the wing, then you'll have to replace the whole lot of the wing because it has been covered and everything has been done. So moving on to other materials, apart from these two, we have fiberglass as well as carbon fiber. So I think nowadays, a lot of manufacturers tend to use fiberglass and carbon fiber because they are much more, like the strength wise is very, very good. Only thing is that if you were to build something like that at home, it's very costly and the materials are very hard to find. And that it's very, very difficult to manufacture at home. So because of that, people, like, unless they are going into the hobby like in very serious manner, for example, designing newer aircrafts which can withstand like a lot of heat or maybe resist water and all that things, you can build out of carbon fiber or fiberglass. But the process of building one is relatively hard than building it from out of KT or MDF or things like that. And then, as I mentioned, newer technology which we have right now is 3D printed aircrafts, which is the easiest part is that you get to print the aircraft at home and then basically glue it together. And the best thing is if you crash it, then you can print that particular section of it and then glue it back together as well. But it takes time. Normally 3D printing an aircraft will take quite a lot of time, but the finishing and the other thing is that if you are very good in designing softwares, you'll be able to design your own aircraft at home and then fly it and test it and things like that without having to download somebody else's design. which in turns you'll learn more about how it works. Anyway, you now know how an aircraft works, how we need to get things working, but you get to know what you have built without having to buy it off somebody, or else download it from another place and then printing it off. And the other thing is 3D printing is relatively getting very, very inexpensive, because a lot of people started doing that, and even 3D printers are relatively inexpensive. And the other thing is there are a lot of places even today, if you go in and search internet on YouTube or whatever, search for how to build a 3D printer, you'll get a lot of information. So if you get that done, even you can build at home. Even I have my 3D printer, which was built at home. I'll be able to show you some of it maybe later on today, if the time permits, or else I'll show you anyway tomorrow as well. So as I mentioned, 3D printing an aircraft is also a good opportunity for you guys to learn and more sort of develop your skills in designing as well as in aviation side as well. Okay, so now you have selected the material. Hassan?
Yes, sir.
I'm getting this request to control my screen. Is that from you guys?
No, sir. You can just continue with the session, sir.
Yeah, because I have to keep on declining that every time. Anyway.
All right, sir. Don't worry. Our technical team would look into it, sir.
Sure, thanks. So now you have decided on what are the materials that you want to buy the build the aircraft. Now we'll talk about what are the common aircraft frame types. Like for example, you can have these particular types which is on the picture. Normally, most commonly used aircraft type is sort of straight leading and trailing edges wing, which is very good for training newer pilots on how the behavior and how to fly an RC aircraft. And the other thing is, when you're talking about delta wings, swept back wings, those particular aircraft needs a bit more speed to fly. So when you have more speeds, it's pretty difficult to control the aircraft unless you're a bit of a seasoned pilot. Or else, if you are good with flying an aircraft, these two are good opportunities for you to sort of enhance your skills in flying an aircraft. And the other thing is, when you're talking about common airframe types, these 6 are not just the types that you can build, but there are others. Like for example, where the wing is mounted comes into play as well. So you have 3 different criteria where you can have your wing, either high mounted, mid mounted, or low wing as well. So likewise, you can choose what are the airframe types that you're going to build, and then how the wing has to be mounted, and depending on your requirement, you can choose how to build your aircraft. Right. So as I mentioned before, you can even go and download these basically blueprints of that particular airframe that you wanted to build. You can search online. There are a lot of places that they provide you with blueprints. And the other thing is that you learn how to read a blueprint as well. Now on this particular picture, it looks like a jumble, but all the details that is required to build your aircraft around this airframe is there. And the other thing is, what I'll do is I'll share some links where you can go and download your particular plan. There are some sites I'll put it on your chat as well at the end of this session, so that you can have a sort of a reference of what are the available aircrafts that is there. And you can even choose whether to have it 3D printed or out of KT or foam bolts as well. So you can have that option on that as well. Okay, now let's get to the power plant. So for example, those days we did not have this much of efficient power plants back in the day for especially RC aircrafts. Some people even tend to use rubber bands, have it rubber banded, and then it basically rotates the propeller and then it basically moves forward. But nowadays the technology is much more advanced, and then we're using what is called as a brushless motor. So brushless motors can be like defined in their particular kV ratings. So over here, I have a brushless motor. So this is connected to a propeller, obviously. And as you can see, this has three wires coming out of it. I'll show you what it actually does. Normally, a motor would have, as you may know, only 2 wires, but this one has 3. And the other thing is that this is rated, if you can see, I don't know, at 1400 kV. So kV is the constant velocity. So that actually says that this particular motor rotates 1400 times per minute at a given 1 volt. So you can get the idea of how many rotations it does, but it does not particularly mean that the higher the kV, that you have more power. It does not work like that. So for example, if you get another motor, this has less kV. This is around 750 kV, but this will have more power than 1400 kV depending on the propeller it uses. Because let's say this is using this size of propeller. I'll come to that later on as well to give you a bit more understanding on how a propeller would work. This would be able to sort of rotate a bigger propeller than this one. So by doing so, obviously, you'll have more thrust coming out of this motor than of this one. So you will have to choose what are the motors that you're going to use, and it depends on the particular aircraft or the size of the aircraft or the weight of the aircraft. And then you can choose what are the motors that you're going to use and what are the size of the propellers that you're going to use. But I'll come into that later on. And also there's something called EDF, electronic ducted fans. I told you about, which is being used on jets. So there are certain EDFs which are rated similarly to normal propeller motors. But having said that, these provides much more thrust than a normal propeller power plant. So this one, as you can see, has an impeller in here. It works similar to a jet engine, but this is not a jet engine. A real jet engine would have an ignition and a combustion chamber and things like that. But this one works similarly to that. So it basically pull in air from the front and pushes it out through a nozzle so that the concentration of the thrust is basically reduced, increased. Because of that, the thrust is more. So, but having said that, if you're thinking that, okay, the EDFs will have more power, so I will use an EDF, that is not how it works. So normally you can get the same performance with a normal propeller engine as well. But the thing is, with the EDF or electronic ducted fans, they are very power hungry. So you cannot use a normal, even let's say a battery that you're using on a normal aircraft. You would need a much more power that can be discharged on a normal battery that we can use only on EDF jets. I'll talk about that when you're talking about batteries as well. But for now, I'll just continue on with the power plants. And also, there are nitro engines. I think these are very commonly used for balsa wood aircrafts. I'm not saying that these cannot be installed on KT boards, but normally, as you know, that when you have a piston which is going up and down, there will be a lot of vibrations. So because of that, the vibration will make the airframe very unstable. So because that's the reason why this is only used on basically either somebody's on waiting room. I'm getting those messages. Hassan, can you check on that, please?
Sir. It's better if you could just ignore the access and just go on, sir.
Okay, right. Is there any questions since I stopped?
Yes, sir, a few questions. I'll just shoot out one. So the question states is, can you please suggest any open source for free aircraft designing softwares with simulation?
Sure. Normally, if you were to design an aircraft, I would suggest go with Explain. This is something that I have used when I was actually when I was doing my degree. On that, there's a separate section called plane design or something like that, which I can't remember. But you can basically build your aircraft. You can give all the sort of parameters to it, and then basically design the aircraft onto those parameters and even test it on that particular simulator. So that's one thing. And the other thing is, if you were to go and sort of learn how to fly, if you want to do that, then you would need basically an RC simulator. So those RC simulators are also available. Something like real flight is, I think I would recommend, because the physics of it is very similar to real flying, and you can change the weather and things like that as well. So I'll put some links to that as well on the chat at the end of the session, and then if you want more information, I'll also give my WhatsApp details, so you can basically contact me and then ask me any questions that you guys have. Right. Shall I move on, Hassan? Or do you have other questions as well?
Yes, sir. Before just moving on, small announcement, like raise hand functions, you can use that to ask questions, but let's keep that to the question and answer session as we have a limited time frame. You can continue, sir.
Okay. Right. So now we'll talk about nitro engines. So these are mostly commonly used, as I said, on the MDFs or plywood built aircrafts, and this can be used on 3D printed aircrafts sometimes, because this actually generates a lot of heat. Normally 3D printed aircraft does not like heat. So if it goes more than 190 degrees Celsius, it will tend to melt. So because of that, we don't normally use it on a 3D printed aircraft, but having some firewalls which can prevent heating, we can even use it on a 3D printed aircraft. And fiberglass, obviously, you can use it as well. So now I have another nitro engine here. This is actually one of the world's smallest nitro engine. This is one of our nitro engines in our Formula Flyers arsenal. So this actually has a 0.049 capacity of an engine. And as you can see, this does not have any way to control, like, for example, no inlet controller or no valve controls or anything like that. I'll tell you why that is. And the other thing is, this black thing here is the fuel tank. So we'll have to have a cylinder and then put fuel. So we put nitro fuel into this. And then you have a piston in this chamber, which actually goes up and down. And as I said, when the piston is moving, it actually generates a lot of vibrations. So because of that, normally we use it on a balsa or MDF or maybe fiberglass or carbon fiber airframes. And the reason why this does not have a throttle control is because that normally these type of engines are connected to basically, let's say, a glider. So what it does is, this will run until the fuel is basically run out, and then normally the aircraft will have to glide back to where it was originally sent off from. So that is the intention of this, and you can see the mounting points of the engine as well here. So this is basically straight on mount onto this thing, and then you have a glow plug on the top where you can have a ignition source, and then you basically heat up the glow plug with some current, and then this normally nitro engines works similar to diesel engines. So it works on the ignition, and then after that you don't need the ignition. Automatic pressurization inside the chamber will ignite the fuel inside, and then it will continue on running until the fuel is drained out. And if I show you another normal nitro engine, so it's pretty much a big difference with that. So you have the exhaust here. So this is the exhaust. And as you can see, this is the throttle control here, where you have the inlet valve opening and closing. This will be connected to a servo. And this is where the glow plug is, as I mentioned before. So it needs a bit of a source to power source to run it. And once it's started, then it will automatically continue on until the fuel flow is there, or else we close up the air inlet and then it will automatically stop. Moving on, I've also got a petrol engine. So pretty much a big difference with the smallest and the biggest. as you can see. So these are quite expensive. And normally when somebody is using something like that, it's going to be onto a very big aircraft as well. Now it has a lot of sensors as well. So now even this one has a sort of a position sensor, which actually tells you how many rotations it's actually rotating. And this sensor is connected to an ignition source. So now, like in normal petrol vehicles, you have an ignition source as well. So this is automated, and then it'll basically have the ignition going on throughout the running process of the particular engine. And likewise in normal car engines, like you have a glow starter here, a glow plug here, and so that's how it works. So this is quite heavy as well. So this is basically can be used on a pretty big aircraft, which can carry up to about 4 kilos or over. Right. So that's about the power plants. And if you were to go on with the power plants, obviously now we talked about the propellers, that this is how it works. And so just to give you a brief introduction on the propellers, so propeller basically works as if a screw. So it rotates and it goes forward. So normally propeller is actually a wing, but actually it's rotating on a certain axis. So similar aerodynamics and effects actually adds onto this as well. But just for you to know, this is how it works. And also, as I said, it works like a screw. And also to talk about the propeller sizes. Now, I have some propellers here. Now, this is a carbon fiber propeller, which we normally use most of the times in normal aircrafts. And this is another plastic propeller. And we have another propeller, which is but much more harder and much more resistant to like bending and all. So these two are pretty much different. We don't use this particular propeller on an electric motor. This is actually there so that you can use it on a nitro or a normal engine. The reason why it is more harder is that this is made out of another material than this one, so that this is not going to heat up. And the other thing is that this is not prone to vibrations as well. I'm not saying that these are not vibrating. These actually, the tips actually do vibrate, but because we are using it on an electric motor, that's actually been counterbalanced as well. The other thing is you need to balance your propeller on a basically a stand. If you search on YouTube or things like that, you'll be able to know how to balance your propeller. Those are basic stuff. Normally you don't need to, but I would recommend that you would balance your propeller before you install it onto your airframe. And talking about propeller sizes, I mentioned that normally a propeller size is mentioned on the propeller. So on this particular case, it says 12 by 6. 12 is the diameter of the propeller. It's in inches. And 6 is the pitch of the propeller. So normally, if the propeller is rotated in one rotation, ideal conditions, the propeller should move 6 inches forward. Likewise, on the bottom picture, you can see that there's one in 10 by 8 and 10 by 4. So the pitch is less. That means you'll have to rotate more to go forward in order to equalize the one which is having 10 by 8 propeller. So this is like basic things. I don't want to get into a lot of details onto that, but this is how a propeller would work. And if you were to use now, for example, you can use 12 by 6 propeller, and another one, same motor, can be used another 10 by another propeller, which is less diameter. That means obviously the thrust is going to be less. However, the motor loading will be less as well. So you'll have to consider those things as well. Right. So there are like so much of variants of propellers that you need to choose. You can choose from. Like for example, if you were to go with a scaled aircraft, it doesn't necessarily mean that you need to have, let's say, you're going to build a C-130 Hercules or something like that. So normally if you see if you were to build something like that, normally if you see the real aircraft, you can see that it has 4 propellers, like 4 blades on a propeller. So it doesn't necessarily mean that you need to put a 4-bladed propeller onto the scale model that you're building, as long as the propeller will give you enough or sufficient thrust to basically carry the aircraft forward or fly the aircraft. And also there's something called variable pitch propellers. Even nowadays, a lot of aircrafts use it, but we're talking about RC models here, so not a lot of people would use it on RC models, but because these are a bit complicated. But you can have a pitch variable pitch propellers as well. That means the pitch of the aircraft propeller will change according to your need, and then you can have better performance as well depending on the flight status. Okay, moving on. Hassan, do you have any questions?
No, so we can continue.
Okay. Right. We'll talk about the electronic speed controllers. So that's one of the main things actually which powers this particular aircraft. So when you say power, now you would think, okay, you put a motor, you put the battery, and then you fly. That's not how it's going to work. So you need to basically have a speed controller to control the movements of the propeller, like the speeds of the propeller. So the speed of the motor in a sense. So you need to have a speed controller. Now what a speed controller would do is basically get the power from the battery and then distribute it onto your aircraft as well as to the motor as well. So now I have a speed controller here. This is rated at 35 amps. You can go way higher as well depending on your requirement, and they will get much more expensive as well. These are like around, I think around 2,000 rupees or something. But having said that, you can increase the efficiency of the aircraft by changing these as well. And the other thing is, now we've talked about this is for electric motor driven aircrafts, and there's another requirement that if you're not having an electric motor driven aircraft, let's say you are flying a nitro aircraft, then obviously you need something to power it with. So there's something called UBEX where you can get these as well. So basically this, what it does is it does the same thing. You get power from a battery and then distribute it without any interruptions throughout the electronics that you have on your particular aircraft. Right. Let's move on to servos. So servos are used to basically, the main priority of the servo is to control the control surfaces of the aircraft. So aileron controls, elevator controls, rudder control. And if you have a nose wheel, normally a nose wheel to steer the aircraft is basically connected to rudder. So you'll have to have a servo to steer it or move the surfaces up and down. Now, most commonly used are micro servos and nano servos as well, but there are standard servos that you can get as well. So this is a standard servo. This will have a rating on it and how much of torque it generates and things like that. And also it will have power ratings as well. And this is a micro servo. So you can see the size differences as well. So as I mentioned before, so depending on the requirement of your aircraft that you want to build, you can choose whether to have this or the bigger one. And the other thing is, the reason why I have the internals of the servo mentioned on this particular picture is that you can have servos which has gearboxes made out of metal as well. So obviously when you have metal servos, metal gearboxes, then you can have more torque onto those servos. So for example, I have this KT build aircraft here. So you have, you can see, you have 1, 2, and 3, only 4 surfaces, only which is connected to only two servos. So because you have 4, basically one servo runs 2 surfaces, and it no, if you were to use a normal servo, then obviously that will tend to break because of the power that is required to move those surfaces. Because when you're flying through the air, the surfaces will have bit of resistance, the air resistance, to move up and down. So you'll need more power. Because of that, then we have metal gear servos, which I have included onto this, so that it will be easier for the servo to move up and down and things like that. So when you are designing an aircraft, or when you are building an aircraft, you have to consider, okay, what sort of a servo that you're going to use. Especially, you don't need to use a bigger servo if you don't need that much of power, and that will in turn will save a lot of weight and a lot of money as well at the end of the day. Moving on. Okay, this is the most crucial part of the build, I would say, because a lot of people would say that RC hobby is very expensive. Partly it's because of this. You can buy a very cheap radio and a very expensive radio. The prices vary quite a lot. However, it depends on your requirement, as I mentioned before. If you're spending quite a lot of time, especially building an aircraft, you would want that to last. As I mentioned, you will eventually crash it one day, will happen. That is how it is. However, you don't want to have a bad radio or a bad radio communication within the aircraft and then make it crash itself because of that. So you would want something reliable, something very good, so that you have a solid signal, that you will not get any interferences from other parties, and that you will have a proper connection through the RC aircraft. Hassan, do you have any questions, Hassan?
Not at the moment, so we can continue, but I guess there is a few announcements to give.
Yeah.
So we've got many requests regarding the language of today's session. People are requesting to do it in Sinhala. It's very unfortunate to announce that it's a bit hard to do it solely on Sinhala because we have participants from overseas as well. So just to hold a fair ground, we are going with English, which I hope would be a fair ground to everyone, and everyone could easily understand.
I can do it in both languages. Like I can do it in English and as well as in Sinhala if you want to do that. Do you have time? What's the time?
That's the issue. So now already it's 7 p.m.
Yeah.
With given the time concerns, we can give an option as you can also shoot your questions in Sinhala, and we would understand. So you can ask your questions in Sinhala, but unfortunately we cannot do the session solely on Sinhala itself.
Okay.
Also, you can get our videos through YouTube and Facebook once the live session is over for your further references as well.
Right. And the other thing is, if they have any issues or concerns, and they can contact me directly via WhatsApp. If you can share my number with them, that's okay with me.
Sure, sir. Okay.
Right. Let's get to transmitter and receiver again. I was saying that there are variant of things that you can buy, especially radio, which is should be a very reliable one. So you don't necessarily have to buy individual radio to your individual aircraft model. So for example, if you have 5 or 6 aircraft models, you don't need to have 5 or 6 radios. So all you need to have is basically this receiver, which goes onto the aircraft, and it will be binded to the particular transmitter, and that it will communicate directly with it, and it will not have any issues with signal interferences unless there is an issue with your transmitter or the receiver. Right, let's move on. So as I was mentioning, there are basic transmitters as well as advanced transmitters. Now, when I say basic, I think you guys might have remembered that I told you about all the control surfaces like ailerons, elevator, rudder, and thrust, or the power has to be there. So already ailerons will take one channel, elevator will take one channel, rudder will take one channel, and thrust will take one. So that means 4 channels already gone. So if you were to buy a transmitter which has 4 channels, you can easily fly an aircraft with all these functions like elevator, rudder, and ailerons. So, and the other thing is, if you by any chance have a radio which only can manage up to 3 channels, what would you do? Like, okay, now you need to go up and down. So obviously that needs to be there. So elevator control, obviously you need to have. So that's one channel. And then you need to have thrust, that is onto your motor. So that's channel number 2 gone. So you have ailerons and rudder. What would you choose? Like, you only have 3. So my recommendation for you guys is to use the rudder, because the ailerons and the rudder basically does bit more similar things, because as I mentioned before, rudder is the one which you use to steer the aircraft, and ailerons turn the aircraft or bank the aircraft. But when you're using a rudder input, normally an aircraft would tend to turn or dip to that particular side anyway. So normally that's why you use something called a coordinated turn. But however, you can get away with a 3-channel transmitter. If you don't have the means to buy a 4-channel or upwards, you can get away with a 3-channel transmitter. But you have, as I mentioned before, you have to get a reliable one. On top of my head, reliable transmitters in the sense, I would give you some manufacturer information such as Futaba, High-Tech, Spectrum. Those kind of transmitters are very reliable, and these are like the frequency levels, they do not jump as well, so you'll have a fixed connection and you would not have issues with signal loss or whatever. But however, have mentioned that this has to be reliable. You need to know that because you're flying the aircraft, it has to be flown within the line of sight. Although these transmitters the manufacturers would say, okay, this will work up to about 7 kilometers. Normal regulation is that you are not allowed to fly 7 kilometers away from you. You need to have a line of sight of that particular aircraft if you're flying that aircraft. And the other thing is, you need to have somebody spotting you as well. For example, somebody needs to be next to you, spotting the aircraft. In any case, if you lose the sight of the aircraft, then that person will know where the aircraft is. Because you're not using any cameras, you're not using any autopilot systems on this. So you need to have a connection very strong to that particular aircraft, as well as you have to know that you're not going to fly away from that particular radius of where you are flying, where the safety area is. And when it comes to advanced transmitters, these are mainly used on drones, but however, you can use the same transmitter on a normal aircraft as well. This will give you all these indications. For example, it will give you the signal strength. If it will give you whether the battery levels are going low, it will tell you the speed of it. If you have sensors on board, it will tell you even how much of fuel you have left. So things like that can be accommodated if you have advanced transmitter. But somebody who is getting into this field, I would recommend buying a basic transmitter, but has to be a reliable transmitter. There are some Chinese clones, I would say, which are not that reliable. I mean, I started using a normal transmitter, and then I switched to a bit more better transmitter because I've seen a lot of difference the way I fly and the confidence level of what you fly as well. Because at the end of the day, if you're thinking, okay, I'm flying this aircraft, I don't know whether this is not going to work after this level, then you're basically in a fear of crashing the aircraft. So you cannot concentrate on flying. But if you know that this is going to be rock solid, this is going to work, then you know, okay, fine, this will work as it should be, and it will work. So as I mentioned, just get something that is very reliable for you guys. And the other thing I want to show you is, so this is a transmitter I have. Right. So this is actually Futaba, normal transmitter. But I've been using this for more than 3 years right now, and it has not given me any issues, and the batteries are there, and you can do all the programming that you require. And this one has more channels than a basic transmitter. I'll talk about more these channels in later on, but I will get onto that with this slide. So there are, when you're choosing a transmitter, the first thing that you need to know is what's the mode the transmitter is. Now there are 4 modes, but normally what we are using in Sri Lanka is mode 2. So mode 2 is basically the throttle lever is on this side and rudder is also here, and elevator and ailerons are on this. But however, if you ended up buying a mode 1 transmitter, not to worry. If the transmitter is programmable like this, you can basically open the transmitter up on the back and then change the gimbals. These are called gimbals on the sides, so that you can have a mode 2 transmitter. But if you are using mode 1 transmitter from day one, obviously you're going to get used to that transmitter, so that you don't need to change it. But if you are used to mode 2 like me, then obviously you cannot straight away go to a mode 1 transmitter and fly the aircraft, because it will get some training. And the other thing is, like, not like normal RC, like cars or boats and things like that. If you have an issue up there, then it's pretty difficult to get the aircraft back in one piece if you don't know what you're doing. So that's the thing that I was always telling you. And there was a previous question as well regarding simulators. So if you can go, and once you get this transmitter, you can even hook this up to a simulator as well. There are a lot of programs like Phoenix, Real Flight, and things like that. You can connect this and then maybe get yourself trained on a simulator first before you fly the real thing. Right, and the other thing I want to show you is, before we get into this one, let me show you another thing. So I told you that this is the thrust lever, and this is the rudder. And as I mentioned, this actually comes in and goes into center and then stops. But on thrust, it actually does not. But on this side, elevators and ailerons works like this. And let's say if you have an issue with, like, let's say you're flying the aircraft and you let go of the sticks and the aircraft tends to move right or maybe move left, or maybe it's pitching up, pitching down. So there are something called trim tabs. So if you want to trim it out, for example, if it is going sideways, then you can give a bit of a trim, and then you can get the aircraft to fly in a straight and level flight. That's how you normally know that the aircraft is totally balanced and that it has not got any issues. Normally, it will have adverse effects, like, for example, you will have wind effects, ground effects, and things like that. But apart from that, you will know when you used to fly in an aircraft, you know, okay, this one is going slightly towards left, slightly towards right. So you just do a trim correction and then get it corrected. Right. Any other questions, guys? Hassan?
Yes, so there's one question.
Mm-hmm.
So as an aircraft have a fuselage to accommodate its components,
Yeah.
how can we build a stable foundation for an RC aircraft to be built upon?
Right. Normally, as I mentioned, now when you're selecting an airframe, you need to know what's the purpose of your aircraft. Like, for example, if it were to to fly, like if you are flying on an aerobatic places or just to fly scaled. I'm not talking about drones as yet, but there are some airframes which can carry payloads and things like that. But I don't want to get into that. But you can decide on what are the areas of payloads that you want to have. So from the design itself, you can say, okay, I'm going to have this much of weight onto this and this much of weight onto that. However, once you build the aircraft, you need to find the CG of that particular aircraft. Like, for example, normally a CG or center of gravity of the aircraft will keep the aircraft straight and level. So normally a CG will be calculated from, this is a basic calculation, from the leading edge of the wing around 1/3 of the leading edge, around 1/3 of it should be where the CG is. So when you're designing something, if you want to have a lot of payloads and things like that, you need to consider, okay, if I'm going to have this payload in this particular area, the CG will move. So according to that, you will have to counterbalance it from the other side. So doing such things, you might end up having an aircraft which is too heavy to fly. So these kind of things you'll have to consider, and then get yourself sort of into a right balance, and then you'll have a proper airframe. Right, Hassan, any other questions?
No, so we can continue with the session.
Okay. If anybody who has asked from Sinhala, I can answer from Sinhala as well.
Not from the technical questions yet, sir. People have just requested to do the session in Sinhala, that's all.
Okay, right, sure. Okay, right, let's talk about the receivers. As I mentioned, like you don't need to have a different receiver you'll have to have different receivers to your different aircraft model. And having said that, you need to have the same brand of the receiver and a compatible receiver to your radio or the transmitter. Otherwise, it will not get bounded to that particular transmitter. And on this particular images that I have mentioned here, there's this FM receiver, which is older technology right now. Nowadays, we're using 2.4 gigahertz and 5.4, 2.8 and 2.4 and 5.8 gigahertz frequencies, which is very reliable, and you have more sort of range as well. So on this picture, you have a Futaba receiver here, and I have a Futaba receiver here, which actually came with my transmitter. Normally, when you buy a transmitter, you'll get a receiver, but if you want to have more receivers, you can buy them separately. These are a bit expensive compared to normal receivers. Normally, this one would cost you around 15,000 rupees. So even if you have an aircraft which costs you less than that, so this receiver and those electronics things that you have will cost you quite a lot. So that's the thing that you need to learn. Like you need to have your aircraft in tip-top condition. And I know that building your first aircraft will eventually crash it anyway. That you'll have to be ready for, and then you'll have to be ready to rebuild it again as well, so that you learn from your mistakes and you know where to improve yourself upon. So like I said, like now these receivers, you might have sort of a normal receiver which has 4 channels, but in this particular case, you have more channels here, which is also numbered as well. So for example, normally this is how receivers are numbered. So you have 1 to 4, which is 1 is always ailerons, and then channel number 2 is elevator, and channel number 3 is throttle, and then channel number 4 is rudder, and also channel 5, 6, or whatever the amount that you have for auxiliary channels, so extras. So for example, if you have a 10-channel transmitter, like I do, now I have extra switches here and knobs as well. What it does is it will control whatever the channel I designate this particular switch into, it will control onto that. So I can have lights to be turned on and off, or maybe landing gears to come down and come up, maybe autopilot systems and things like that. I can program with this and then tell it to do on the aircraft itself. But normally basic 4 channels are ailerons, elevator, throttle, and rudder. From number 1 to number 4. That is how it is all the time, unless the manufacturer mentioned that it's not the way. But normally, most of the known manufacturers use this method. And the other thing you need to know is that when you're connecting your electronics onto this receiver, for example, if you have accidentally connected throttle onto ailerons, you need to know that when you plug on your battery, that ailerons are basically active. Like, for example, I showed you that on the transmitter, the throttle lever is always going down. That means this is at 0 and this is, let's say, 100, right? So if you have connected this, the thrust connector onto this, that means this is at 50, right? So this is 0, this is 100, this is at 50. So as soon as you connect it, if the transmitter is also on, that means you are basically telling the ESC that the throttle is at 50%. So what does an aircraft would do? Like it will power up, right? So it will power up to 50%. If you have your arm or anything valuable, or maybe somebody else holding that particular aircraft, that person might get injured. So you need to know that you have connected cables correctly, and the polarity should be correct as well. I'll get into that. And you need to know that that's the first thing that you need to know, is that you need to turn on your radio, the transmitter first, before you turn on your particular aircraft. And you need to check all your control surfaces, control switches, that it is not, like for example, if I left it at up and then turn it on, now this has fail-safe systems. So if I turn it on, then it'll give me a blink and say that, okay, thrust lever is up. I can put it down and then it'll stop. That's only how it's going to work. But some radios might not have that feature. So if you have something like that, then you need to check all these control surfaces, control levers are at the right position before you turn on your particular aircraft. Because there are some instances that normally when you plug in, the motors will start and then it will go and then injure somebody, or maybe damage the aircraft or somebody around you. So that's how it is when it comes to receivers. And then you have to wire it properly as well. So when I said wiring it, so when it comes to servos, you have this connector here. So this is always color coded. So you can see, so now normal color coding is basically white, red and black, but nowadays you can get the cables which has orange, red and brown as well. And there are older versions which had blue, red and black as well. But any of these which has to be connected at the right orientation. And that always, so the white in the sense has the signal coming through, and then red and black is for positive and negative power. Right, let's move on. Now, this is also very important. Hassan, were you going to ask me a question?
So I'm sorry to interrupt. We've got a few announcements to give.
Yeah.
So already the link for the attendance form is posted in the chat here. It would be also shared on the Facebook page and also through the YouTube live chat. So the participants who are here, who are joined with us here today, please do fill the attendance form from right now itself. This is a major criteria for the certificate for the participation certificate as well. So please don't miss it. The window to fill this form would be open from now on, and in 20 minutes time, it would be closed. So don't miss the opportunity. Also, later on during the session, we will be sharing a feedback form to get your feedback on the sessions so we can correct ourselves and bring you the best. Thank you.
Okay, Hassan, thank you. Is there any other questions that is pending?
Currently, no, so we can continue.
Okay, right. Right, let's get into one of the main parts as well. Again, if you were building a electronic or a motorized RC aircraft, then you would have to choose a battery. So normally those days we used to have nickel metal hydride batteries or nickel cadmium batteries. I'm sure that you guys have seen these on, even nowadays you can see this batteries on toy graded cars and things like that. But now lithium polymer has come a long way from the days it was started, and the discharge rates and everything are very high, and it's very efficient compared to nickel metal hydride and nickel cadmium batteries. So nowadays we're basically using lithium polymer or LiPo batteries for these aircrafts. And there is another type of a battery which is they have tested on, which has more power, but it has not been out yet. I'm only talking about the materials and all these electronic things and all that, which is available for us to get at this stage of the year or the day, and that it is easy to source. So let's talk about these lithium polymer batteries. These are not to be sort of messed with. Now this has very high discharge rates, and especially if that particular battery is damaged, it is more prone to get into fire and things like that. So we need to be very careful with that, and especially if you have a crash and if you have a damaged battery, I would suggest that you would not use it and dispose it as mentioned on the manufacturer. However, this on this picture it says how the battery is basically connected together. It's connected with cells. I have some batteries here. Right. So normally battery would have a connector, as I mentioned before. So this will have to be similar to what you have on your, let's say, because the battery is connecting to the ESC, you'll have to have the same connector on the ESC side as well. I'm not necessarily saying that you have to, because there are some converters that you can get, but it's easier for you if you have the same connector on your ESC as well. So for example, now this is a battery which is rated at 1500 milliamps. This is a 3-cell battery. You can see the cells here, 3 of them. And you have this balance charging port here. This is what you use to balance charge the 3 cells. So basically it will charge cells individually and then it will be balanced out as well. And then this connector is the discharge connector. You have it on a Dean's plug or a T-plug connector. So if you were to have your ESC connected, you can basically connect it straight away, right? But if you have a battery which has an XT60 connector like this one, you cannot connect it. So either you remove this connector and then replace it with an XT60, or you'll have to get a XT60 to Dean's converter to connect it. But if you're basically building an aircraft, then obviously you should be able to change this over, or maybe when you're buying your parts, you can choose, okay, what's the connector type has to be. And the other thing you need to know about batteries are, so for example, now this is a 1500 milliamp battery. This one is rated at around 25 C. I don't know whether you can see at this stage. Now this is a 1500 milliamp battery as well, but it says 4 cells. So you have more, one extra cell than the other one. And the other thing is it has more discharge rate. For example, now this has 120 C. So this is ideally, as I told you guys before, more discharge is required for EDFs. EDFs takes quite a lot of power. So because of that, these are mostly used on EDF powered aircrafts. And when it comes to drones, obviously you use these as well for racing quads and things like that. I'll talk about it on when we're talking about drones tomorrow. So this has a much more higher discharge rate than this one. So because of that, you'll be able to get much more higher power, but for a shorter time. So EDFs does not quite a long time. So I mean, it lasts quite a long time. Normally an EDF jet will be able to fly maximum up to about 2 to 3 minutes. But whereas in a propeller aircraft, you'll be able to even fly at up to about half an hour. So that's quite a bit of a difference. However, you don't get the scale look if you were to, fix a propeller onto a jet. So, there are some compromises that you need to make. But however, these are the compromises that you have to think of. And these EC3 connectors are not that sort of common, but they are also there. It's not there. Anyway, it's not that commonly used in Sri Lanka. Let me put it that way. Mostly used are XT60 as well as Dean's plugs. Now even Dean's plug is a bit more safety-wise. It's not that great as an XT60 connector. Even when you see the picture, you can see that the XT60 connectors are made a bit more ruggedly and a bit more properly, whereas Dean's plugs are basically not that good in manufacturing process as well. So I would recommend you go with an XT60 connector. And let's talk about battery charging. Now you cannot charge a LiPo battery in normal charging sort of a power pack or thing like that. You need to have a balanced charger for that. So otherwise, the thing is the battery will be dead before you know it, or else damaged. And the other thing is the charging will be basically when you have a balance charger, it will be maintained properly. Otherwise, you might end up having a burst battery or maybe fire damage as well. And the other thing is you need to have you'll need to have something like this if you can to store your batteries when it's charged or maybe it's not used as well. Because this is basically a fire retardant material, which if you have a fire in the batteries, then it will be only contained onto this. So you'll have, as I mentioned, you need to have a balance charger for this. And the other thing is, I want to show you, this is actually a battery cell checker. So if you are out in a field and if you want to know the battery levels are good, because normally like when you're using a battery, normal batteries, we will use it until it drains out. But for LiPo batteries, you cannot do that. You need to have a bit of power left, like 20% of the power left on this particular battery until it goes, if it goes beyond that, then it will damage the battery. So you can basically plug this in and check the battery levels of this particular battery. So now you can see the number 1 cell is this much, number 2 cell is this much, number 3 is this much, and number 4 is this much. So all in all, it have this much of power. So because of this COVID issues and all that, I have not been able to use this battery for a long time. Now it has started a bit of an puffing effect on this battery, which is not a good sign because it has to be discharged if you're not using it. So on this particular balance charger, I have one right here. So it's like this. There's an option to make it discharged. So what you need to do is basically discharge your battery if you are putting it into a storage or maybe putting it away because you're not flying. Now, normally we used to fly every Saturdays, but since we're not doing that, might as well get all the batteries discharged and keep it on a safe place, like a safe bag or something like that. So if your battery is like this, then I would highly recommend throw it away, like not to just throw it away, but you have to dispose it carefully as per manufacturer's information. Now, I have a battery here. I think you can see the difference between these two. So this is puffed up. It is in a bad state. I would not recommend using this because it might be able to hold power, but when it is getting discharged, it might catch fire as well. So it might be, you might be flying your aircraft and the battery gets heated up to a point that it will catch fire, and then it might do some damage, do a lot of damage to your aircraft and do some damage on people who's below it or maybe some property as well. So you need to be very careful. And especially when the batteries are charging as well, you need to have a proper eye on this because you need to know whether these batteries are charging properly, whether the cells are charging properly or not. And that you need to check it regularly because normally these batteries will take about around half an hour to 45 minutes, depending on the cell and the amperage of the battery. So you need to check whether it's being charged and that there's nothing shorting in the circuits or things like that. And especially it's prone to get, like, we've seen a lot of people having very bad issues, very bad experiences when the batteries gets exploded. So you'll have to be very careful. And mind you, all these things that I've mentioned about the equipment, especially engines, the motors, the propellers, they can sort of injure somebody or injure yourself. So make sure that you are very cautious of what you're doing and that you are very well trained on what you're doing, and that follow all your safety precautions before you attempt to do these things. Right. Let's talk about model aircraft optional accessories. Onto your particular aircraft, but let's keep it as a model aircraft for now. So if you can even install something like a landing gear set. So this is a retractable landing gear, which looks nice. It has a shock as well. And this, by doing this, this is not gonna make it a drone, obviously. This is for aesthetic reasons. And obviously you need to find out whether this is gonna add a lot of weight. As you can see, this is a bit heavy. This is for a bigger model aircraft anyway. So you need to find out whether this is worth doing so. So some people might put on lights and maybe like retracts and all these kind of things, and you might not be able to fly the aircraft because it has gotten more heavier. So likewise, as I mentioned, okay, Tavin's Dias is raising his hand. Shall we ask a question from you, Hassan? Hassan?
Yes, it would be much more appreciated, Mr. Thavin, if you could keep your question and we could discuss them in the question and answer session because of the time constraints.
Right. I'll try to go through this a bit fast if required. Then we'll have a bit of time for question and answers. So the as I was saying that you can even install lights like landing lights and navigational lights and things like that to make the appearance of the particular aircraft much more nicer. And if you go furthermore, you can even have autopilot systems and data transmitting systems, the camera, FPV systems. Having those kind of systems installed on your particular aircraft will make it a drone. I will tell you why that is tomorrow, because normally if you have a data acquisition system installed on your aircraft, that means it's a drone. So you're not supposed to, it does not get into the category of a model aircraft. So it will be treated as a drone. And if you don't have proper authorization to fly a drone, then you're gonna have some issues with the local authorities, or else even your neighbor might be complaining that you're spying on them. So let's not do that. We'll talk about the rules and regulations of drone flying and things like that tomorrow. But let me just wrap it up by saying that, like for example, now this is an autopilot system, which is a very small thing, similar size as a receiver, I would say. Right, this is an aircraft autopilot system, and on this particular unit, you can basically have the aircraft to fly on its own. You can give waypoints to fly to these particular waypoints and come back. Even it can do takeoffs and landings. And the other thing is that the best thing is for a learner, you can let go of the sticks, and this unit will automatically level off the aircraft and fly on a straight and level flight. So that's one of the main things that you need to think of. Like if you are a newbie or a new pilot, these kind of units will help you to gain more experience on flying, and then making flying a bit more easier for you with these autopilot systems. But having said that, putting an autopilot system will make your aircraft a drone. And those autopilot system has a GPS unit as well. For positioning, it will tell you your height, your speeds and everything. So this is a GPS unit, which is connected to that autopilot system. And you have a onboard telemetry system, onboard data transmitting system here, which will work separately from your transmitter and receiver. And you can have your data onto a laptop or maybe a TV screen or things like that. So you will have your cameras as well if you want to connect and see what the aircraft actually sees. And you can even have it as if you are flying on a real aircraft. You can have your cameras to move sideways or up and down, depending, as I said, depending on your radio capabilities. You can have that as well. But I'll talk about those kind of things tomorrow. So as I mentioned, so these kind of things are a bit sketchy right now, because even civil aviation regulation has not specifically said that there are 2 rules for drones as well as for model aircrafts, but they are working on it. So in the near future, there will be some sort of rules coming out for those of who are willing to fly model aircrafts, because nowadays they treat everything as the same. So let's see what's going to happen in the future. Let me go to the last slide of today's on the aircraft assembly. So we talked about all of these things and how this is connected. This is how a motor is connected, and a LiPo battery is connected, ESC is connected, receiver is connected, and everything is here on this particular picture. So now you know how an aircraft would work, how to wire it up, how the motors should be there. And the other thing is, like, for example, if you have a normal motor, if that particular motor is rotating in a particular direction, if you want to reverse that direction, then you would reverse the polarity of the connectors, right? But in these brushless motors, you have 3 wires. What you need to do is basically disconnect 2 of the connectors, and then change it, and then connect it back in again, and then it will rotate on the other direction that you would want to. So that is how it is. Now, Hassan, do you have a bit more time for me to sort of go through some 3D printing as
Sure,
well?
sir. Sure, sir.
Right. So that's the basics of building an RC aircraft. As I mentioned, like, I've put on all these links for where you can download these models and things like that on the web. There are some which you have to pay, but there are a lot of places that you can get it for free. If you can download it, and then you can even build it yourself, which is very easy. And then all you need to do is have this particular electronics, and then you're good to go. You're ready to fly. But as I mentioned before, please be careful with what you're doing. Please adhere to all these safety instructions that is given to you by the manufacturer, especially when you're dealing with LiPo batteries, and especially when you're activating an aircraft. As I mentioned, it can go horribly wrong. I'm telling you with experience that happened to me. So make sure that you don't get yourself injured by doing so. Right. So let's move on. Another example of how to build your aircraft is 3D printing. Now, as you may all know, that 3D printing sort of has done a lot of things right now. For the last, I think 3D printing only started about 5, 6, around, let's say about 1 year back. So I was fascinated about the idea as well, and then I did some research, and then I built my own 3D printer. And up to today, it still works. And up to today, I do get a lot of 3D prints done. If I can show you some of the examples. So this is an aircraft which I'm designing right now. This is 3D printed. So as you can see, everything is customizable because you are designing it. You can have everything for your requirement. This is very light as well, because of the size and all that, obviously. But this is plastic. So this kind of, like, for example, the geometrical symmetry of the particular aircraft might not be able to get the same results with just normal KT boards or foamy manufacturing methods, but we can do that as well. And the high precision items, just such as this one, this is a actual jet engine replica on a Trent. I believe it's a Trent 900 engine. So this has been 3D printed. It has not been finished yet. This takes a lot of time. That's one of the downsides of the 3D printing process. However, you can do a lot of things with it. Now, normally, if you are good in designing software, especially 3D designing, you'll be much more happier to use this kind of technologies. But having said that, there are a lot of opportunities where you can learn these things, and then you do it as a sort of a profession as well. You can have a business with 3D printing as well, especially prototyping parts, even day-to-day parts you can print and then manufacture for yourself, even for others if they require. So normally how it works is basically you do a CAD design, and then that CAD design will be converted into a G code. So to convert that into a G code, there are some softwares as well, like Cura and something like that, then you can basically convert that and then get it printed. So this is how normally 3D printing work. I'm sure that a lot of people have seen this. This video has been sped up. This is actually not my printer. This was taken from YouTube. I did not had any time to record my things till even today. So this is actually an impeller which they are printing right now. You can see the precision of the print, and that you will not be able to manufacture this sort of an impeller at home without a 3D print. And if you can see the size of it, it's a much more accurate as well. And this is something that I've done for Sri Lankan Airlines. So this is a USB port which is in Airbus A330 variant aircrafts. Normally this ports, the front part actually gets broken by usage. So in order for us to replace one of these parts, it will cost around to put a OEM or original manufacturer part, it'll cost around 90,000 rupees each, just for that USB part. Normally aviation parts are very expensive. So we came up with an idea of 3D printing. This has not been implemented yet, but this is sort of like a test part that we've done. We can do it less than 2,000 rupees per part, in-house design and 3D printing, and then we can install it. However, normally aviation parts will have to be certified, so that the certification is a bit of an issue. However, they are working on it. This is sort of an example for you guys, so that you know that what are the opportunities available for 3D printing in the near future. This is one of or two of these engines which were printed at home. Custom Prototypes is basically my company that I run. I'll send you a link to that as well if you want more information on that. And now, Hassan, shall we move into question and answers?
Sure, sir. So that brings us to the end of today's presentation session. And we have this session, same thing, tomorrow as well. So before moving into the question and answer session, we have a little mind game here. So it's just quiz time. Refresh your mind on what we learned today. Just 7 basic questions through Kahoot. So just a couple of minutes and the Kahoot session will be ready. So all you have to do is the Kahoot link would be given to you through the chat, and it would be also shared on Facebook and YouTube. Just have to log in through the Kahoot page, and a special code would be given to you. Through that code, you can log in to the room.
In the meantime, shall I put those links on the chat as well, Shah?
Yes, sir. That would be helpful.
So this is one of the sites that I know of that will provide you with free plans. For those of you who wants to build your own aircraft, you can go into that and download. Also, there are other sites such as Thingiverse and perhaps some favorite, but do have a look on it and then see.
So the links are also being shared at the moment.
Now, let me just inform you guys who are willing to look into drones tomorrow. The YouTube channel that I run right now has some information on newest technology of drones. So go on to that and then have a look around, because some of the drones you may have never seen, and the capabilities of them you may have never seen. So it's best if you can go on to that as well and then have a look around. And as I mentioned before, you can ask me any questions on WhatsApp. John, shall I put my number as well here?
Our technical team is taking on that, sir. Your contact information would be shared on our platforms.
Yes.
So yes, the link and the code for Kahoot session would be shared in a couple of minutes. All you have to do is have a name. Please have a proper name, because winners would be just, you know, announced and cheered up on during the session as well. So all you have to do is get logged in with the code, have your proper name there, and we'll have 7 basic questions. The questions would be shared on screen here. So you can see the questions and the answers to select through the session here. And all you have to do is select the correct answer from your device that you have logged in. Each question would have 20 seconds of time, and we'll have a 5-minute open window for people to log in.
Hassan, also to mention about our club, whoever is interested in building an aircraft, they can contact our club as well. Because of the COVID situation, obviously we are not flying these days. However, once the COVID situation is sort of okay, and we are able to sort of move around and all that, we will start flying back again. And this is located in Kadawatha. Whoever is interested in coming and joining our club, please let us know. And there's this Facebook page which I've also shared on this chat. They can come in and join us, and then we'll be able to even train them as well on flying a sea aircraft as well.
So I can see participants are coming in. So I'll share the screen to let you guys know how other participants are logging in.
Okay.
Hope you all can see my screen here.
Yeah, I can see.
It's just a fun game, guys. So, you know, nothing serious, just to cheer up with what you learned today. So before the window closes, log in, and then we can start the game right away. Great, I can see a lot of participants joining in. So currently we have 47, and participants are still coming in. Yes.
And hope these questions are from my session today. So I think everybody was listening in. I'm sure that you can answer in as well.
Just to test how well you remember today's session.
I'm sure it was a bit fast because normally we would do it with some practical things as well. But obviously, because of the situation, we cannot do that. Let's see.
I think we'll go for 100 participants here first, and then we'll start the round, I guess. Oh, people are still coming in. Okay, I'll allow a lot more people to join. So until our participants join in, I guess we can go for a few questions.
Sure.
So there was a question about the battery discharge rate. So a participant wanted to know about the battery discharge rate, and he or she prefers it to be in Sinhala.
Right. Battery discharge rate එක කියන්නේ කොච්චර current එකක් මේ battery-ෙන් එළියට දෙනවද? ඒ කියන්නේ අපි හිතමු දැන් පොලිමර් යනවා මිනිස්සු ඒ පොලිමේ 10 දෙනෙක් යනවා එකපාරක් එළියට. ඒ කියන්නේ විනාඩියක් ඇතුළත 10 දෙනෙක් එළියට යනවා. එතකොට මිනිස්සු 10 දෙනා එළියට යන්නේ. තව පොලිමක යනවා 20 දෙනෙක් විනාඩියක් ඇතුළත. එතකොට වැඩිපුර වෝල්ටේජ් එකක්, ඒ කියන්නේ අපි මිනිස්සු වෝල්ටේජ් එක කියලා ගත්තොත් වෝල්ටේජ් එක එළියට යනවා. එහෙම තමයි ඩිස්චාර්ජ් රේට් එක කියන එක ඒ කියන්නේ සමරයිස් කරලා කිව්වොත් එහෙම අපිට higher discharge rate දැන් හිතන්න මේ බැටරි එකේ තියෙනවා 45C මගේ කැමරා එක පේනවද දන්නේ නැහැ 25C discharge rate එක C rating එක මේ බැටරි එකේ තියෙනවා 120ක් එතකොට මේකේ obviously discharge rate එක වැඩි නමුත් මේකේ තියෙන electrons ගාන මේකට වඩා පුළුවන් තරම් කියන්නේ හිමීට තමයි එළියට දෙන්නේ මේකත් 4 cell battery එකක් මේකත් 4 cell battery එකක් මේකේ 4200 milliamp මේකත් 1500 milliamps වලට වඩා මේකේ voltage එක මේකේ මෙයා එළියට දෙන්නේ පොඩ මේකේ දෙනවා ඉක්මනට. ඇත්තට මේකේ ඇතුලේ හදලා තියෙන ඒ කියන්නේ materials වල වෙනසක් තියෙන්නේ. මේකේ ඉක්මනට එළියට voltage එකක් දෙනකොට දැන් power hungry මොකක් හරි කියන්නේ power එක වැඩිපුර use කරන්න අවශ්‍ය කරන දැන් මම කියවනේ EDF කියන motor එකට වැඩිපුර power එක අවශ්‍ය වෙනවා. දැන් මම මේ battery එකෙන් මේකේ 4200 දීලා මේ EDF මේකම මට fly කරන්න බෑ. ඉතින් මම ගොඩක් වෙලාවට C rating එක වැඩි බැටරි එකක් යූස් කරනවා ඒ කියන්නේ discharge ඒ කියන්නේ වැඩිපුර කරන්ට් එක ගන්න පුළුවන් ඒ කියන්නේ දැන් මේකේ සමහර විට මේකෙන් මට පැය භාගයක් fly කරන්න පුළුවන් වෙයි එකම එයාක්‍රාෆ්ට් එක නමුත් මේකෙන් මට විනාඩි 2ක් නැත්නම් 3ක් තමයි fly කරන්න වෙන්නේ මොකද මේකේ discharge වෙලා ඉවරයි මේකේ discharge වෙනවට වඩා ඒක තමයි basically කතන්දරේ discharge rate එක Robin Shashi has raised their hand.
So, අපේ හසන්ට පොඩි ටෙක්නිකල් ඉෂුව එකක්
Alright, okay.
හස අපි හෝ දැම් අන්ෆෝර්චනලි හසන් කිය අතේ තමයි තියෙන අපේ කහුට් සේෂන් එක මේ අපි තව ක්වෙස්චන්ස් කීපකට යම් ජොයින් වෙනකම් Give me a second. Yeah.
No problems.
Okay. Contact details and all that. So we have another raised hand as well. So we have a question about can you please suggest any open source or free aircraft designing softwares with simulation?
මම හිතන්නේ මේ ප්‍රශ්නට උත්තරයක් දුන්නා. Free designing softwares ගොඩක් free නෑ ඇත්තටම. ගොඩක් ගණන් දැන් කැටියා කියන software එකත් ඒකේ license ගන්න ඕනේ. නමුත් ඉතින් මම කියන්නේ ලංකාවේ කට්ටිය කොහොමද license use කරන්නේ කියලා. මේ මම නම් ටික කියන්න SolidWorks හොඳයි. කැටියා හොඳයි මොකද Dassault Systems ලගේ තමයි දෙක මම personal use කරන්නේ කැටියා කියන software එක. ඒක හොඳයි design කරන නමුත් ඔයගලන්ට ඒක දැන් design කරපු එක ඔයගලන් test කරලා බලන්න නම් මම කිව්වේ අර explain වගේ softwares වල ඒ කියන්නේ ඒක normally aircraft simulator software එකක් නේ. ඒකට ඔය design කරපු aircraft එකේ ඒ කියන්නේ parameters ඒ කියන්නේ sizes CG එක කොහෙද තියෙන්නේ මොකද්ද aerofoil එක මොකද්ද ඒ විස්තර ටික දැම්මට පස්සේ ඔයාලට ඒ සිමියුලේටර් එකේ check කරලා බලන්න පුළුවන් aircraft එක fly කරන characteristics මොනවාද කියලා. ඉතින් ඒක තමයි ඒකට උත්තරේ.
Thank you sir. Is there any resource you recommend to follow up if we are designing the RC airplane from scratch?
දැන් මම ඒ ටිකට links ටික දැම්මා පොඩ්ඩක් chat එකේ බලන්න මේ තියෙනවා Aerofred කියලා එකක් site එකක් aerofred.com කියලා ඒකේ තියෙනවා ගොඩක් plans download කරගන්න පුළුවන් free අනිත් එක ඒකේ අහනවා ඔයා හදන ඒ කියන්නේ මැටීරියල් එක මොකද්ද KT board වලින්ද foam වලින්ද නැත්නම් 3D print කරනවද නැත්නම් laser cut කරනවද මේ MDF එකක් එහෙම කියලා. එතකොට ඔයාට පුළුවන් එතනින් select කරලා ඔයාට කැමති එක download කරගෙන ඊට පස්සේ එතන මාරම ලේසි. ඒ කියන්නේ ඔයා print ඔයාට එක print කරලා KT board එක අලවලා ඊට පස්සේ කපලා එහෙම ගන්නත් පුළුවන්. ගොඩක් වෙලාට එහෙම තමයි කරන්නේ. ඊට අමතරව 3D print lab thingiverse එකේ ගොඩක්ම තියෙන්නේ 3D print කරන ඒවා මේ ගන්න. ඒකෙත් තියෙන ගොඩක් මේ aircraft designs download කරගන්න පුළුවන්. 3D print lab කියන එක මම දන්න තව එකක්. නමුත් ඒකේ ඇත්තටම සල්ලි ගෙවන්න ඕන. ඒ සල්ලි ගෙවලා තමයි මේ plan එක download කරන්න වෙන්නේ. අනිත් එක එකම දේ ඒකේ තියෙන්නේ 3D print කරන්න පුළුවන් plans එක විතරයි. නමුත් ඔයගලන්ට කියන තව එකක් තියෙනවා flight test කියලා. ඔයගොල්ලෝ සමහරවිට දන්නාත් ඇති YouTube එකේ channel එකක් තියෙනවා ඒගොල්ලන්ගේ. ඒගොල්ලන්ගෙත් තියෙනවා. නමුත් ඒගොල්ලන්ගෙත් සල්ලි ගෙවලා තමයි ගන්න තියෙන්නේ plans. මම දන්න සල්ලි නැතුව ගෙවලා ගන්න පුළුවන්. ඒ කියන්නේ සල්ලි නැතුව ගන්න පුළුවන් එකකට තියෙන්නේ ඔය Aerotech කියන මේක. ඒකේ ගොඩක් තියෙන plans download කරන්න පුළුවන්.
Okay. We have another one. As an aircraft has a fuselage to accommodate its components, how can we build a stable foundation for RC aircraft to be built upon, and more suitable way to secure components?
Yeah, now I think I've answered that question as well.
Yes.
Hassan,
These
basically.
are, these are like clarification.
All right. Okay.
Sorry, had a few technical issues going on, and I guess now we can go for the Kahoot session. And soon as the Kahoot session finishes, we can go for the Q&A.
Okay.
So sorry for the interruption.
That's okay.
So yes, why don't we start the session right now itself? Okay, I'll lock the room right now. So we've got 240 participants, and let's go. So hopefully you can see my screen. And here goes. Each question has 20 seconds, okay? Yes. So how many channels are required to fly a powered model that has full house controls? As you know, through today's session, we had a discussion on this. And airplanes functions are controlled through channels. So how many channels are needed to have a full house control? Yes, the time's running, guys. And great. So for a full house control, we need 4 channels, and 68 of the participants had answered it correctly. So let's see who's leading. Great. Through the first question with 984 points, Prabhash is leading. Moving on to the next question. Which channel or receiver output in a 4-channel radio is usually assigned to the elevator control surface? Another general question which was discussed. Clock's ticking. Yes, answers are coming in. So I guess sir mentioned about having 3 channels as well. During somewhere there, the answer is hiding. Great. So 79 participants have answered it correctly. So let's see who's on the lead. How the tables turn. So Amod, I guess, he's on top right now with 1,837 points. Moving on. How many wires are in a typical servo extension cable? We saw a lot of wires and color codes. I hope you guys remember. And here goes the time. Great, 108 people had answered it correctly. And moving on. Wow, now Deshan is leading with 2,696 points. Great, great. Moving on to the next question. It's a question 4 out of 7. If an elevator servo freezes on an aircraft in flight, the pilot will find it most difficult to. Is it to pitch the nose up or down, roll back the plane, or yaw the nose right or left, or is it increase or decrease the throttle? Yes, so the answer is pitch the nose up or down. And what a surprise, again, Amod is on top with 3,431 points. So moving on to the fifth question. When one is balancing a battery, they are equalizing the voltage between two or more cells, or are they adjusting it so that power is constant throughout flight? Or is it charging it in a small increments to eliminate the effects of voltage drop, or making sure it is at the same charge level as a person's other? All right, the answer is equalizing the voltage between two or more cells. Going on to the points, we have a new lead here. It's Kaminder with 4,251 points. Great. So the sixth question, for a traditional aircraft, a good rule of thumb is to have the center of gravity approximately where? So it was a question where Sir did demonstrate as well. So hope you all remember the right answer. We'll see who gets it correct. Yes, the answer is approximately 1/3 of the way back from the wing from the leading edge. So Sir had a small demonstration as well, and he showed from which point it is. We'll see who gets the correct answer here. It's Kisal now with 4,568 points. Remember, guys, the quicker you answer, the more points you get. So going on to the last question of the quiz today. So a 2,700 kV motor with no load should spin the shaft at 2,700 RPM for every volt supplied, spin the shaft at 270 RPM for every volt supplied, or spin the shaft at 2,700 RPM regardless of voltage, spin the shaft at 270 RPM regardless of the voltage. And the correct answer is spin the shaft at 2,700 RPM for every volt supplied. So that brings us to the end of the Kahoot session. Shall we reveal the winner? The third place goes to Amod with 4,934 points. Second is Kaminder. And first place goes to Kisal with 5,281 points. Congratulations, Kisal. So we have runners up at Asanka M and Deshan as well. Congratulations to everyone here. So that brings us to the end of the Kahoot session. Moving on, now it's your time to clarify all your doubts. So as mentioned below, we have a special website for questions, and the links were posted earlier too. So it would be advised to drop your questions there through the link. It would be much more feasible for us to get your questions. Or now it's a time for you all to use your raise hand function and ask the question yourself.
I see two of them. Yeah.
Using the raise hand function. I hope a member from our technical team could unmute and let them ask their question. Technical team members.
Hello.
Yes, Bruce, your mic is unmuted. We can hear you, Bruce.
Thank you. Thank you very much, sir. That was a really insightful lecture. So I have a few questions regarding the practicality of model flying in Sri Lanka. So in Sri Lanka, where can we specifically, according to your experience, where can we buy all the materials in a budget-friendly way, as well as from trusted and reputable brands and names? So where can we is there any specific shop that is a specific shop or community where we can buy it?
Yeah, Bruce, the thing is, post-COVID, there were some shops, to be quite honest with you. and I think they have sort of had to sort of close down because of that. However, there are a lot of Facebook communities in Sri Lanka where they basically, buy and sell these things. Especially if you were to join with a sort of a club like us, then we will be able to sort of source these things from outside as well. For example, now we are doing a sort of a batch order for all these aircraft equipments and parts from overseas, just for our members, so that we can sort of build up a community. Previously, we used to order from even AliExpress and things like that, but as you all may know, that the delivery process and everything is very difficult. And on top of it, if you were to buy an aircraft frame to get it down to Sri Lanka, there's a bit of a hassle going through TRC and all these entities. But having a club like ours, which is also registered with the civil aviation, I'm not saying that it's only us. There are a lot of other clubs as well around this country. If you go into Facebook, maybe Google or YouTube or things like that, you'll be able to find these communities. And especially what we can offer from our club is sort of like, if you were to buy or even build or laser cut things, there are people in our particular club who can do this for you. And there are importers of these parts and things like that who can do that for you as well. I don't want to mention any names because of these copyright issues and things like that, which I don't want to go into. But if you were to contact me or any of our club members, I've posted the link for our club as well onto this. You may be able to